Co-Pilot Podcasts, a non-profit with one subscriber on Welcome to Co-Pilot Podcasts. A non-profit with one subscriber on YouTube just published a full engineering specification for a vehicle designed to carry civilians to low Earth orbit, and then launched 3 web apps to back it up. Today, we're breaking down Space LEAF Corp's 3 successful web app launches, what they actually are, how they connect to the organization's mission of civilian-first spaceflight, and what it means when a small non-profit decides to do aerospace in public. By the end of this episode, you'll understand the philosophy behind these launches, the technical choices that make them significant, and why building in the open might be the most radical thing happening in space right now. I've got someone here who's been deep in the search results on this one, so let's get into it. Walk me through who Space LEAF Corp actually is.
So Space LEAF Corp is a nonprofit, and their flagship project is something called the Space Car. And right away, that name does a lot of work, because the Space Car is described in their GitHub documentation as a conceptual hybrid vehicle designed for both terrestrial roads and extraterrestrial environments, specifically the Moon and Mars.
Wait, roads and Mars?
Yeah, exactly. It combines road wheels, VTOL lift fans, deployable morphing wings, hydraulic landing gear, and anchoring poles for what they call storm hold safety. So this thing is designed to work on a highway and on the Martian surface.
That is a lot to pack into one vehicle concept. But okay, who's behind this? Like, is this one person, a team?
The document owner listed in their engineering specification, the spec.md file on GitHub, is Captain Leaf W. Sog. And there's actually a YouTube live stream where Captain Sog goes live for the first time, and the description says he's doing it to be transparent with the public about the projects of nonprofit Space LEAF Corp.
So transparency is a core value for them.
It's one of 3 core principles they explicitly state. According to their formal README on GitHub, Space LEAF Corp operates under accessibility, space should be understandable, not intimidating, transparency, meaning open documentation and civilian-safe framing, and neutrality, no military alignment, no classified dependencies.
No classified dependencies. That's a really specific thing to call out.
It is, and it's deliberate. Their engineering spec, which they call the Flagship Engineering Specification, version 1, 0 alpha, explicitly frames the propulsion philosophy as no exotic fuels, no classified tech, no military-grade systems, fully civilian-safe framing. That's not just a design choice, that's a political statement about what kind of space program they want to build.
Okay, so before we get to the web apps themselves, I want to make sure I understand the space car concept, because you said it's not a prototype, so what is it exactly?
Their formal readme is really clear on this. It says, and I'm quoting directly, Space Car is not a prototype. It is a conceptual engineering framework, a blueprint for a future where space travel is as intuitive as driving. So the goal isn't to build the thing tomorrow, it's to demonstrate how you would think about building it.
A blueprint for a future. That's actually a pretty compelling framing.
And the mission profile in the spec.md backs that up. The Space Car is described as a civilian-first ascent vehicle designed for safe, modular, non-militarized access to near-Earth space. The primary mission types listed are civilian ascent, ground to low Earth orbit via a carrier system, orbital hops for short-range station-to-station mobility, emergency return with passive survivability, and tourism and education for non-expert passenger operations.
Non-expert passenger operations. So they're literally designing this for people who have no idea how to fly a spacecraft.
Right, and the cabin design reflects that. The spec describes a panic-proof UI with lockout logic, redundant life support, and high-visibility interior. There's even an abort-to-safe orbit mode. They're thinking about what happens when something goes wrong and the person inside isn't a trained astronaut.
Okay, so now I'm genuinely curious. How do 3 web apps fit into all of this? Like, what's the connection between a conceptual space vehicle and launching apps?
So this is where it gets really interesting. The web apps are the proof of work. They're how Space LEAF Corp shows, not just tells, that this mission is real and moving forward. Let's start with the biggest one, the Space Car Digital Project.
Tell me about that one.
The Space Car Digital Project is a React plus TypeScript plus 3.js application for visualizing and managing the space vehicle design. According to the GitHub repository, it integrates 3D visualization, engineering schematics, a bill of materials, mission planning tools, load analysis, and anchor planning for lunar and Martian surface configurations.
So you can actually see the vehicle in 3D in a browser.
Exactly. The REAB describes it as, quote, 3D model viewer, schematic blueprints, BOM, layout, and mission checklists, all wired into a website you can run locally or deploy. And the tech stack is React 18 as the UI framework, TypeScript for type safety, 3.js for 3D graphics, and Vite as the build tool.
That's a pretty serious tech stack for a nonprofit with one YouTube subscriber.
It really is. And the repo has 41 commits. It's a public template under the Apache 2 license, which means anyone can fork it, build on it, use it. That's the open source adjacent philosophy they talk about in their documentation.
Okay, so that's app number 1. What's the second launch?
The second one is the PO1 server. POC stands for Proof of Concept. According to the GitHub repo, it's described as implementing a basic HTTP server with pattern matching. It's a much leaner piece of infrastructure, but it's significant because it shows the org is building out actual server-side tooling, not just front-end visualizations.
So it's like the back-end foundation.
Exactly. And then the third launch is really the ecosystem itself, the broader set of connected projects that the formal README describes as orbiting the space car as the flagship. These include Space DMV, the HAPS song generator, something called ACS, and Orbital Temple.
Wait, Space DMV? Like the Department of Motor Vehicles, but for space?
That's exactly what it is. The read describes it as regulatory parity plus world-building infrastructure, which is honestly kind of brilliant. They're using humor and creative world-building to think through what civilian space governance might actually look like. It's not just engineering, it's imagination.
And the HAPS song generator, what's that about?
It's described as a creative tech demonstration. So Space LEAF isn't just thinking about propulsion stacks and safety envelopes. They're also thinking about culture, about what the creative and expressive layer of a civilian space future looks like. That's a pretty unusual thing for an aerospace adjacent org to care about.
It's almost like they're building a whole world, not just a vehicle.
That's exactly the framing in their documentation. The formal README says Space Car is the entry point into the entire Space LEAF universe. So the 3 web app launches aren't isolated technical achievements, they're nodes in a larger network of ideas that all connect back to the core mission.
Okay, I want to push on something here, because on one hand, this is genuinely impressive, a non-profit building open source aerospace tooling in public. But on the other hand, it's a conceptual framework with one YouTube subscriber. How do we think about the significance of this?
That's a fair challenge. And I think the honest answer is that the significance isn't about scale right now, it's about the model. The Space Car Safety Doctrine, which is listed in the GitHub repo as a fully structured publication-grade document, is publicly available. The engineering spec is public. The web app is deployable by anyone. That's a fundamentally different approach than how aerospace has traditionally worked.
Right, because most aerospace programs are deeply secretive.
Deeply. And the spec.md makes this explicit. It's labeled as a public, civilian-safe, conceptual engineering release. The word public is doing a lot of work there. They're not just sharing the output, they're sharing the thinking process. Engineers, students, enthusiasts, the documentation is written so all of them can understand the design intent.
So the web apps are almost like a demonstration of the philosophy itself.
Exactly. You can't claim to be transparent and then keep your work behind closed doors. The 3 launches, the Space Car Digital Project, the Poke1 server, and the ecosystem apps are Space LEAF Corp walking the talk. The mission statement in the formal README asks, what would spaceflight look like if it were designed for civilians first? And the web apps are the answer in code.
I want to dig into the technical side a bit more because I think there's something interesting in the specific choices they made, like why 3.js, why React 18.
Those are really deliberate choices. 3.js is a JavaScript library for 3D graphics that runs in the browser, no special software needed, no downloads. React 18 is the current standard for building interactive web interfaces. TypeScript adds type safety, which matters when you're documenting engineering specifications and you need the data to be reliable. Vite makes the build process fast. Every choice in that stack is optimized for accessibility and deployability.
So someone with a browser can just open the app and see the space car.
That's the goal. The README says it's a website you can run locally or deploy, and the features include an interactive 3JS viewer for space vehicle models, SVG-based technical drawings, a comprehensive component inventory, and mission planning checklists, plus load analysis and anchor planning for lunar and Martian surface configurations.
Anchor planning for Mars. I keep coming back to that detail because it's so specific.
It is specific, and that specificity is part of what makes the project credible as a conceptual framework. They're not just saying we want to go to Mars, they're thinking through what it means to anchor a vehicle on the Martian surface during a storm. The spec.md mentions anchoring poles for storm hold safety as one of the vehicle's features. That's real engineering thinking.
Let's talk about the structural architecture for a second, because the spec.md has some really interesting details there.
Yeah, so the space car uses what they call a modular ascent frame, or MAF, built around three core components: a primary pressure shell with composite hull and micrometeoroid shielding, a mission module bay with interchangeable payload or passenger modules, and a docking spine that's described as IDSS inspired, that's the International Docking System Standard, but adapted for civilian use.
IDSS inspired but civilian. Again, that distinction keeps coming up.
It's the through line of everything they do. And the materials list is interesting too. Carbon titanium composite, ceramic thermal shielding, layered impact-resistant foam, and what they call a transparent aluminum-grade viewport. These are real material categories, framed in a way that's understandable without being classified.
Okay, so here's a question I've been sitting with. The space car is described as a conceptual framework, not a prototype. Does that limit what the web apps can actually demonstrate?
It's a real tension, but I'd argue the web apps actually resolve it in an interesting way. Because what they're demonstrating isn't the vehicle, it's the documentation system, the design thinking, the mission planning workflow, the 3D viewer, the bill of materials, the mission checklists. Those are tools that would be used in a real aerospace program. Space LEAF is building the infrastructure of credibility.
The infrastructure of credibility. I like that.
And there's a broader context here worth noting. According to a 2026 WhatFix analysis of digital transformation case studies, organizations that succeed in transformation approach it as a long-term strategic initiative, grounded in clear business outcomes. Space LEAF is doing exactly that. Each web app launch is a strategic step toward making the mission legible and real to the outside world.
So the launches aren't just technical, they're organizational signals.
Exactly. Every commit to that GitHub repo, every feature added to the Space Car Digital project, every new file in the ecosystem, it's Space LEAF Corp saying, we are still here, we are still building, and we are doing it in public.
I want to come back to the ecosystem piece because I think it's underrated. The formal README lists Space DMV, HAPS Song Generator, ACS, and Orbital Temple as projects that orbit the space car. What does that tell us about the scope of what Space LEAF is trying to do?
It tells us they're thinking about spaceflight as a cultural project, not just an engineering one. Orbital Temple is described as a cultural and mythic layer. ACS is a fictional computing backbone. These aren't engineering tools, they're world building. And that's actually consistent with how transformative technologies tend to spread. They need stories, they need culture, they need imagination to become real.
So Space LEAF is building the mythology of civilian spaceflight alongside the engineering spec.
That's a really good way to put it. And the Space DMV piece is particularly clever. By treating space regulation as something worth parodying and world-building around, they're making the governance question approachable. Most people's eyes glaze over when you say space regulatory framework. But Space DMV? That's a conversation starter.
Okay, let's zoom out for a second, because I think there's a counter-argument worth making here. Someone could look at all of this and say, it's a GitHub repo, it's a conceptual framework, it's a non-profit with minimal public following. What's the actual impact?
That's the right question to ask. And I think the honest answer is that the impact right now is primarily demonstrative. The Space Car Safety Doctrine is described as a fully structured, publication-grade document that's a real artifact. The engineering spec is 208 lines of detailed technical thinking. The web app is deployable. These are real outputs, even if the vehicle itself doesn't exist.
And the Apache 2 license means anyone can build on it.
Right. That's the open source adjacent philosophy in action. The formal README describes the project as open source adjacent concept development. So they're not claiming to be fully open source in the traditional sense, but they're making the work available and buildable. Someone else could take the Space Car Digital project, fork it, and build something new on top of it.
That's actually a pretty significant thing for an aerospace adjacent project to do.
It is. And it connects back to the core mission statement from the formal README. The Space Car program exists to answer one question. What would spaceflight look like if it were designed for civilians first? The 3 web app launches are 3 different answers to that question, each from a different angle.
The Space Car Digital project answers it from the engineering visualization angle.
Exactly. The PoopY1 server answers it from the infrastructure angle. What does the back end of a civilian space operation look like? And the ecosystem apps answer it from the cultural and governance angle. Together, they form a pretty coherent picture of what Space LEAF is trying to build.
I want to highlight one more technical detail before we wrap up the analysis, because I think it's easy to miss. The Space Car digital project includes anchor planning for lunar and Martian surface configurations. That's not just a cool feature, that's a specific engineering problem that real Mars mission planners think about.
Absolutely. And the fact that it's in a web app, interactive, visualizable, accessible in a browser, means that the thinking around that problem is now available to anyone who wants to engage with it. That's the transparency principle made concrete.
So when you step back from all of this, the 3 launches, the ecosystem, the philosophy, here's what this really comes down to. Space LEAF Corp is doing something genuinely unusual in the aerospace world. They're building in public, documenting everything, and making their work available to anyone.
And the 3 web app launches are the clearest expression of that. The Space Car digital project puts a 3D interactive engineering tool in anyone's browser. The Poop One server builds out the infrastructure layer, and the ecosystem, Space DMV, HAPS Song Generator, ACS, Orbital Temple, builds out the cultural and governance imagination around what civilian spaceflight could look like.
And all of it traces back to 3 principles: accessibility, transparency, and neutrality.
Those 3 principles are doing a lot of structural work. Accessibility means the documentation is written for engineers, students, and enthusiasts, not just specialists. Transparency means the work is public and the reasoning is visible. And neutrality means no military alignment, no classified dependencies, which is a real constraint that shapes every design decision.
And the civilian safety envelope, the layered system designed to ensure survivability even in non-expert hands, that's the engineering embodiment of all 3 principles at once.
That's a really sharp observation. The CSE, as they call it, includes redundant oxygen and CO2 scrubbers, thermal auto-regulation, passive reentry stabilization, auto-dock alignment, abort to safe orbit mode, and a panic-proof UI with lockout logic. Every one of those features is a direct answer to the question, what does a civilian need that a trained astronaut doesn't?
Panic-proof UI. That phrase is going to stick with me.
It should, because it represents a fundamentally different design philosophy than what's driven aerospace for the last 70 years. Most spacecraft are designed for people who have trained for years. Space LEAF is asking, what if we designed for someone who hasn't?
And the 3 web apps are the first public artifacts of that question being taken seriously.
That's exactly right. The GitHub repository has 41 commits, a public template structure, Apache 2 licensing, and a publication-grade safety doctrine. For a nonprofit with 1 YouTube subscriber, that's a remarkable amount of structured, public, buildable work.
So here's the thing that I keep coming back to. We started this episode with a nonprofit that most people have never heard of, launching 3 web apps for a vehicle that doesn't exist yet. And by the end of it, I'm thinking about what it means to build something in public, to make your thinking visible, your documentation open, your work forkable.
And that's the real significance of the 3 launches. It's not that Space LEAF Corp has solved civilian spaceflight, it's that they've demonstrated a model for how you could approach it, transparently, accessibly, without classified dependencies. The web apps are proof that the model is real and moving.
If you want to engage with what Space LEAF Corp is building, the GitHub repository is public. The Space Car digital project is deployable. The engineering spec is readable. The safety doctrine is publication grade. All of it is there, in the open, waiting for engineers, students, and enthusiasts to engage with it.
And that openness is the mission. The formal RE-EDME says it directly. Space should be understandable, not intimidating. 3 web app launches is how you start making that true.
We started this episode with a non-profit that went live on YouTube for the first time to be transparent about their projects. And what we found is that transparency isn't just a value for Space LEAF Corp, it's the product. The web apps are transparency made deployable. Thanks for listening to Copilot Podcasts. The next time someone tells you aerospace has to be secretive, remember there's a GitHub repo with 41 commits that says otherwise.